Earth's crust is dripping into the interior. Researchers have found evidence of lithospheric dripping occurring beneath the Central Anatolian plateau in Turkey. Beneath the Konya Basin, a depression located on the Central Anatolian plateau, Earth's crust is slowly dripping deeper into the planet. This process, known as lithospheric dripping, is gradually reshaping the surface geology of both the basin and the surrounding plateau. The phenomenon was only recently identified on Earth, and geologists are still exploring its various expressions. Analyzing satellite data, we observed a circular feature in the Konya Basin where the crust appears to be sinking or the basin deepening, said Julia Anderson, a geophysicist at the University of Toronto. This led us to examine data beneath the surface, where we found seismic anomalies in the upper mantle and a thickened crust, indicating high-density material and revealing the process of lithospheric dripping. As the lower part of Earth's crust heats up to a certain temperature, it becomes sticky and begins to drip downward, similar to honey or syrup, but on a much larger and slower scale. When a drop forms and descends, it pulls the crust downward, creating depressions or basins. As the drop sinks into the mantle, the surface rebounds and bulges with a spreading effect. Researchers have only recently started to understand this process. Through modeling its evolution, Anderson and her team identified an area of the mantle where lithospheric dripping is happening beneath the Arizaro Basin in the central Andes. Now, after careful surface geological analysis and experimentation, they have discovered another instance of lithospheric dripping beneath the Central Anatolian Plateau, which has been slowly rising over time. Previous research suggested that this region has gained around 1 kilometer in elevation over 10 million years due to crustal dripping. The Konya Basin is sinking at a rate of about 20 millimeters per year, which may not seem significant, but the subsidence in a rising plateau warrants further investigation. The research team found that the broader plateau region is in the rebound phase of lithospheric dripping, after molten rock from the crust sank into the mantle, while the Konya Basin is forming a second, smaller drip. They validated their model through laboratory experiments. In these, the researchers used a high-viscosity silicone polymer called polydimethylsiloxane to mimic Earth's sticky lower mantle, while a mix of polydimethylsiloxane and clay simulated the upper mantle. Ceramic beads and quartz sand acted as the crust. By pressing a seed-like object into the upper mantle layer, they recreated the dripping process and observed the results. Within 10 hours, the first drip began to form and descend. After 50 hours, the second drip started. Neither drip was associated with horizontal surface deformation, only vertical changes, which matched the Konya Basin. The results suggest lithospheric dripping is a multi-stage process, explaining the simultaneous uplift and subsidence in the Central Anatolian Plateau. The team published their findings in the journal Nature Communications,